Okay, so the last thing from chapter 2 is applications where it has two parts. Meaning, if we were using the formulas, you would require to use two formulas. Now, we're still going to use the TVM solver, but sometimes it means plugging it in the TVM solver twice. Not always. Sometimes it just means plugging in $2 amounts, and you have to be careful when you plug them in to understand what's positive. These are where it's really important that you understand and plug in the correct number that's positive, the correct number that's negative. So this is where it matters. Okay, so usually you're either given $2 amounts or 2 time periods. And so that's the first example is 2 time periods. All right, suppose Alex decides to deposit $2,000 at the end of each 6-month period for 8 years. All right, so every 6 months, he's saving $2,000. So he's depositing $2,000 into an account every 6 months for 8 years. At 5% interest, compounded over the same time that he invests the money in. Then Alex leaves the money alone with no further deposits for an additional 5 years. Which means whatever money's been accumulated to that point is going to sit in the account and earn the 5% interest compounding semi-annually. To find the amount after the 13-year period, which you have to break it down into the 2 different time periods because she's doing 2 different things over those time periods. You have your first 8 years, so we'll do that. We have the first 8 years, and then the last 5 years, right? That's the total 13 years, but you have to separate it into the 2 different time periods because it matters, right? You're doing different things. With the first 8 years, she's accumulating money by adding it in the account, so it's the sinking fund accumulation type. In the last 5 years, she's not doing anything to the money but letting it sit there and earn compounding interest. So it's the 2.2 case, where it's just present value, earning interest to get me a future value. Alright, but I have to do my 8 years first. So again, we're going to use the TVM solver. N is my compounding period, which is every 6 months or twice a year for 8 years. So 16 times she's going to add $2,000 into this account 16 times. Our interest rate is 5. Present value, well, when she opens the account, she plugs the $2,000 in at the end of the month, so it starts out with nothing. The present value is nothing. She's making regular payments of $2,000, and she's making those payments into an account, so that's a negative number, right? Because it's out of her pocket and going into the account. She can't touch it for 13 years. And then we're going to figure out at the end of the 8 years, how much money did she accumulate, right? How much money was there at the end of the 8 years? Because that amount is going to sit there for the last 5 years, and that's important to know. All right, those are both 2's, right? Because our compounding period is 2, our payment period is 2. And so we're solving for this first. So you plug it in, carefully making sure that you type it in. And you get, at the end of 8 years, she's accumulated $38,760.45 in change. All right. And so this is going to become a part of the second answer, the second piece, to get to my answer. All right, so this is the second part, the last 5 years. So again, N is 2 times 5 now, so 10. All right, 2 is my pay period over 5 years, so compounded 10 times. Interest rate, that's still 5. Present value, though, those are still 2's. This future value becomes the present value for the last 5 years, right? Over the first 8 years, we've accumulated $2,000 plus interest every 6 months for 8 years. At the end of those 8 years, she stops making payments. So now that money is just sitting there. It's now the present value for the last 5 years. She still can't touch it, so when I go plug it into the present value, I'm going to plug it in. So basically, you're going to move it up from future value to present value. When you move it up to present value, it's still a negative because she can't touch it. Payments now are 0, right? She's no longer making any payments. That's 0, and we're still searching for the future value. And this is actually the final answer. That's the complete future value. That's the accumulated part plus the last part, which is just earning interest, right? And so over the 5 years, it's going to sit there, earn 5% interest, and it accumulates to a grand total of $5,754.16. All right, so that's an example of there's two parts because there are two dollar amount, or not dollar amounts. Well, actually, there's one dollar amount. There's two time periods. Two time periods where I have to take care of the dollar amounts over those two different time periods. And so, again, you have to do it twice. That's an example of, again, I would have to use the compounding formula and the sinking fund accumulating formula and figure this out if you're using formulas. The next example. Alright, suppose you, this one's a little easier. Suppose you open an account with an initial deposit of $10,000. Then you add $50 at the end of each month in the account to save for the future. Right, so there's $2 amount in this account. You've got the initial present value where you're going to plug $1,000 in at times 0. And then every month after that, you're going to plug, so you're going to accumulate it by plugging $50,000 in and then add interest to all of those money values. The account earns, for 5 years, the account earns 3.8% interest compounded monthly. How much money is yours? How much money is interest? All right, so we want to figure out how much will it accumulate? What's the future value? And then how much is yours and how much is interest? So we have those two answers, two questions to answer. All right, so first, now in this case, if you were using formulas, you would have to use two formulas. You'd use the compounding formula for the $1,000 and the accumulate and sinking fund formula for $50. Well, what's nice about the TVM solver, all of the dollar amounts are there. You only have to plug it in this case, once. Compounding period is 12 for 5 years, so 60 times. I'm going to put $50 in the account. Our interest rate is 3.8. And this time, we're going to fill in, there's not going to be any 0 cases. We're plugging in an initial deposit. That's my present value. And so I'm going to put $1,000 in at times 0. It's not empty at times 0. Then we're going to add regular payments. So negative 50. So those both need to be negative, and they have to be negative in this case. I'm putting $1,000 in the account at the start of the 5 years. And then every month after that, I'm adding $50 out of my pocket. So both of those are negative. I'm going to solve for the grand total. All right, how much is in my future value? Payment period, compounding period are both 12. All right, well, how much do we accumulate at the end of the 5 years total in both money values? After 5 years, we've accumulated $4,507.10 and change. Some of that's the money that you deposited, and some of it's in interest, and I want to figure out what those are. All right, so the first thing I'm going to figure out is what are all the payments that we made. Alright, all my payments. Well, all of the payments would be the one-time deposit of $1,000 plus the 60 times we're going to put in $50, right? Those would be the N times our payments, right? $50 is going in there every month for 5 years. So 60 times we're going to put $50 in the account. So we put $4,000 as yours. All right, that's how much money was invested. Interest then would be the $4,507.10 minus the amount you invested. And so that's $5,500, not $5,000, $507.10 would be the interest. All right, so that's your interest. Alright, next example is a pension problem. They like pension problems on the final exam because, again, most people will eventually get a job and put money away into a pension. And so this is how pensions work. You work at a company for so long and they have a 401k or some type of investment that you put money into, some type of retirement plan, right? And they take a little bit of money out of your check every month, and the employer also usually adds to that too. Sometimes it's a 50-50 split, sometimes it's not. Alright, but some of the money in your paycheck gets taken out and putting into your retirement to save for the future. And so you save while you're working, and you plan for retirement. Usually, again, retirement plans typically are 25 years. And so you've got two different time periods. You have your working years and your pension plan, your retirement years. And we start with the plan. How much do I want to have at the end of my working years? And so I start here with my pension. Alright, plan, which my pension plan would like to retire. So Meg's pension plan is an annuity guaranteed return 5% per year, compounded quarterly, so it's a quarterly type. She'd like to retire with a pension of $12,000 per quarter. So every 3 months, she takes $12,000 out of her pension and uses it for bills and to live off of. For 25 years. So she's going to have enough in her pension that she can do this for 25 years when she retires. Alright, so the plan is for 25 years. Then, well, we need to know how do we make that happen. And so the working years. The saving, right? You're working and you're saving for 45 years while you're working and putting it into your pension. Part of your paycheck goes into the savings for your pension. And so she's going to work for 45 years before retiring. How much must she and her employer deposit each quarter? So again, it's typically a split between you put some in from your paycheck and your employer, gives as much. Sometimes it's a 50-50 split. You put in 50% and they put in 50%, but not always. Again, it just depends on how the employment set it up. But we need to figure out, well, what are those payments? How much are they going to put into the pension every quarter, every 3 months, so that her pension will work out the way she wants it to? Alright, so we start with the pension plan. N is our compounding period, so quarterly, 4 times a year for 25 years. So 100 times, she's going to get a payout of $12,000 from her pension. Interest is 5%. Present value, well, that's what we want to solve for, not present value. Oh yeah, that is what we want to solve for. We want to solve for present value. How much does she need to have in her pension in order to make a retirement work, right? In order for her to get payments of $12,000 every quarter. The future value is 0 because once the 25 years are up, that's the plan, is to last for 25 years. At the end of 25 years, if she lives that long, there'll be nothing left in her pension. Her pension will be exhausted. Alright, so we're looking for how much does she have to have in her pension so that she can get payouts of $12,000 every quarter for 25 years. At the end of 25 years, there would be nothing left in the pension. Alright, so our payment period and our compounded period are both 4s, right, because it's quarterly. And so we solve for this. This is what we're solving for, which is going to become a piece of the working years. What large sum of money does she have to, and again, it's usually a large sum of money. You have to have a big chunk of money because you're going to live off of this money. It's going to earn a little bit of interest, but you're going to live off of it. Alright, she has to have in her pension when she retires a little over $500,000. $682,816.07 in order for her pension plan to work out. Which, that's what I need. It's going to become a part of my working years. Alright, so now the working years. Alright, well, this is the plan. Now how do we make the plan happen? Alright, well, N is the compounding period times time. Compounding period is still 4, but time, she's going to work longer than she's retired. She's going to work for 45 years. So that's 180 payments total. I is still 5. It's in the same account. Alright, so she's saving money. So we're looking for, right, in the working years, we want to know how much must she and her employee deposit each quarter. And so we're looking for the payments. That's what we want to solve for. That's our final answer to the question that we're looking for. When you open a pension, it opens and it's nothing in the account. Right? You don't have anything in your pension until you get that first paycheck. Right? It's 0. And then when you get your first paycheck, part of the paycheck goes into your pension. The future value, well, that's the goal. Well, the goal is to have this amount in your pension when you retire. And so that present value amount, which would have been negative on the calculator, goes into the future value amount in your working years. And so when you put it, so you're basically moving it from present value to future value. When you do that, make make it positive. Right, and the compounding period and payment period is still quarterly, so those still are 4s. Alright, and this is what we're solving for. Well, how much money does her and her employer need to invest in the pension every quarter, so every 3 months, for 45 years? So 180 times, they're going to have to put in this amount. And so when you solve for the payments, it's going to be a positive number, or a negative number. $1,021.40. So they're going to put in, again, some of it comes out of your paycheck and some of it the company puts in, but every quarter, $1,021.40 goes in to your pension, so that you can accumulate this amount, and that's the amount you need in order to make your pension plan pan out the way you want your pension plan to pan out. And so, like I said, that's the pension plan. And so pensions are always broken into what's the retirement plan, what's the working year plan. All right, and there's usually a time period. Time period for the retirement is usually somewhere around 25 to 30 years, and you usually work for 30 to 50 years, somewhere in between. All right, and so that's the last example. We'll do more of these in the mixed review, but those are basically the types that you'll see. All right, some of them are the hard cases. 3 and 1 are the ones where you actually have to fill out your TVM solver twice. And when you have to fill out twice is when you've got time periods that are separate, right? Both of these had time periods that were different. If it's all over the same time period and you just have 2 different money amounts, that one's the easier case because you just plug in both those money amounts. But you have to remember when you plug them in, they go in as negatives. All right, so make sure when you're taking it out of your pocket, it's negative. And it's important. If you don't remember those negatives, you won't get the right answer in that case. And that finishes up chapter 2. And I will do one more set of notes, because the hard part about chapter 2 is not necessarily the plugging it into the calculator. The hard part about it is knowing what to plug in, when to plug it in, and which case it is. All right, and we'll do that. Practice mixing it all together, because that's the way it's going to show up on the quiz. It's going to be all mixed together. And so I have one more set of notes. It's not anything new. It's just the same type of problems where I've mixed it together in those videos.